So let's now consider the case of two objects that are moving, and how do we solve that? So, for example, let's say that we have a river and we have a log on the river, and the log is going down the river, and on the log is a cockroach, and so it's going under a bridge. Okay, and someone up here drops a rock and they want to hit the cockroach as it's floating past. So let's say the river is moving here with a velocity v1, okay, and we'll say that this is object 1 and the rock is object 2. So v1 is going to be 1.15 meters per second. Okay, and let's say that this height right here, x2, is going to be, let's say the initial height is 2.75 meters. And so what we want to do is, I want to know at what angle theta would the cockroach have to be from the rock in order for it to fall and hit exactly as it's there. Because what happens is the cockroach is going to be here when the rock falls, and then as it moves, then this is going to fall and hit. So these things happen simultaneously, the falling and the moving. And so there is the problem. Okay, so this moves some distance x while that's falling. Well, how far does it move? Well, x1 is just x1. So x1 is going to be v1 times t. We're assuming it's going at constant velocity. So we know that x equals x naught plus v naught t plus 1/2 a t squared. At constant velocity, then the acceleration is 0. Now, while it's doing that, this object is falling. And so x2, again, if we put our origin here, say down's positive, so g is this way, okay, then x2 is going to be 1/2 gt squared. So the v2 naught equals 0. Okay, so it's going to fall and hit. Well, now we're going to have these two equations right here and right here. And we look at it and we say, well, how do we solve this? Well, what helps me sometimes is actually, mark it and say, what do I know? Okay, so I know this, I know this, I know this. The only thing I don't know is t. Down here, I know that. Now, if I had t, then I could find that distance. If I know this distance and this distance, I can find the angle. Okay, so that's what I'm trying to find, is the angle. And so all I got to do is find this distance, x1. That's going to be v1 times t. Well, I've got v1. I just got to find t. I can find the t from. So x2 equals 1/2 g t squared. And so t is going to be the square root of x2 times g. Okay, so that's going to be the square root of 2 times the 2.75 meters divided by 9.81 meter per second squared. So t is going to be 0.749 seconds. Now plug that into the other equation. x1 equals v1 times t. So x1 is now going to be equal to 1.15 meters per second times the t, which is, we now know, is 0.749 seconds. So x1 comes out to be 0.861 meters. Now we have that x2 and x1, we're looking for this angle right here. So we know we were given that x2 is 2.75 meters. We just calculated that x1 is going to be equal to 0.861 meters. So I want to find theta. So we look at that and we say, okay, so tangent of theta is going to be the 0.861 meters divided by the 2.75 meters, opposite over adjacent. So we work backwards and we find that theta is going to be equal to 17.4 degrees. Okay, and so that was the angle. Now, we were using this as x1 and x2. I could have called this y right here, and then think about this as a two-dimensional problem. Now, in this case, we're able to think of it as one-dimensional problems, two one-dimensional problems, because we have two objects, each of them moving in one dimension. And so that's how we approach this. In Chapter 4, we're going to have one object moving in two dimensions. And so that'll make it a little bit more complicated of a problem. But we got to get through Chapter 3 first. Okay, but I'm going to do a couple more Chapter 1 problems now, in which we are doing the problems here, one-dimensional problems with multiple objects moving, and we'll see how that works. Okay, so that's where we are right now.